So what we did was we looked at things like, if we call it like the extent of underreporting, the discrepancy between the measurement with the prediction from doubly labeled water and the measurement from the dietary survey. If there's no kind of underreporting, you would expect that difference not to change with things like BMI or sex or things like that. And so the biggest thing that falls out of that is that people who are heavier, who are higher BMI, underreport much more. And that has some major consequences. If you're saying something causes obesity, and okay, we can get into whether BMI is a good measurement of obesity or not, but
basically you're saying the level of bias is different for obese and non-obese people.
Yeah. So, and it gets progressively worse the higher your BMI is. So the consequence of that is if you then try and link an exposure to somebody's BMI, you're systematically biasing what you're measuring. And so then you can say, let's take an example. This is not from the data, but let's just take an example. If people underreported their intake of fruit, for example, as they got bigger, you would make an association between healthfulness of eating fruit and it protecting you from obesity, but it wouldn't be true.
Right,
all it is that people who are larger tend to underreport eating fruit.
Yeah. You're basically you're basically saying that your results show that these sort of statistical mirages are bound to show up in data like this.
Yeah, right, because of that bias. And so what we did was we showed was that if you screen the data using the tool that we produced, you can massively reduce those biases. So by only including data that are plausible, then that bias with the BMI it's not completely removed, but it's massively attenuated. And so the consequence of that is that what we've provided to the field is a tool that they can use to improve the survey work. And it's relatively cheap to do because all you're doing is some calculations and you can do it retrospectively.